Hello everyone. This is the second part of structural modeling using modeler. Previously, we have talked about how to download and install the modeler, what are the prerequisites of the modeler, how to make the input file of query sequence you want to make a structure of that, and how to identify best possible template structures. So these were the four things we discussed in our previous. Now in the next part of this tutorial we will go through the process that how to run modeler to find the best possible model of our protein, that is the query sequence. So we will go through all the things previously. First we will go through the step one, that is to build the profile, and in that process let's go and see the files. This is the folder. I am just making it I just modified it to make it clear. These are the files. For example, build profile, you can that is the Python script for build profile. I'll show you from where I found it. These are the four templates we identified using the blast result. And now let's go and start to make the profile. I'll show you how I got that script of build underscore profile. That is maybe you can follow my previous tutorial for that. So let's go and into that folder. That is the homology modeling folder, right? Homology modeling, and then enter. Yeah, now we are here. So let's run this first command of build the folder command here. Let's see. Okay, and here mod 9.25 space build.profile.python. Now here you can see that the file is running. All the commands will take a bit of time, so let's see. It's running the command here, and you can see that now the log build underscore profile.log file will be generated in that homology modeling folder, which will give you the details of the analysis, that how it's building how it's checking the profile. So let's see and wait for a moment here. Let's see. Now it's done. Now let's go and see what are the results here. Here you can see that here this is the build underscore profile.log. So all the details related to the profile, building a profile is here. All the log, all the comparison between different between the sequence and the structures here, the z-scores of the histogram is also mentioned here. So all the values are here, and the profile is built. So all these we may go in the details of these later on. So now what we have to do next. Next part of the tutorial is to go and compare the templates. And to compare the templates, what we need to do is to download to run that script of compare templates, which is already downloaded from the example available on the website. In that example they use specific PDB structures to compare, which were for their own analysis, and those were the names are mentioned. However, for our ease, we have changed the name of our templates from T1 to T4. So we will change the name step by step. For example, first change the name of the T1, then T2, T3, and T4, right? And the other two are actually we only have 4 templates, so we will remove the next options which are mentioned in this example. Those are they use probably 6 templates to compare. So now we have changed the script as for our requirements, and now we will save this into another file with the name of compare.py, so that we can use it for our analysis. And for py is for the Python extension, because all the scripts are run on Python, as you know that. So compare.py, yes, and then either we can double click it, or we can run the, or don't double click it, but just follow the protocol, that just go here and write mod 9.25 space compare.py and enter. So after entering the command, you see that it ran very quickly, and the comparison is done. So after that, you go to the compare.log file, and in that log file, when you go at the end of all the descriptions are available here. For example, you can see that the comparison and other matrices as well, like here you can see distance comparison between different templates, their relationship between each other, sequence comparison and all. But if you go at the end of the file, you can find the most similar template with the query sequence, or query sequence which we want to print the structure. So here we say that T1A is most closely related to our sequence of interest. So now the next part, now we have selected the T1. Now we will go and align that T1 template with our query sequence. So for that, we will perform the analysis and use the alignment command, which is already downloaded from the website of Modeler. So let's see what we have to do. Here we'll go and just close this one, and now we use the next script that is for the alignment. And in that alignment here, we will change the file name. For example, here this is 1bdm, so we will change the name here to, what we have to do here, we will change it to T1 template, and then T1A, and just repeat the name, and T1 again the .pdb, which is already downloaded here, and also the name of the query sequence file, that is the query sequence.ali here, and this one to query sequence, right? So after that, we will just do all the needful changes required in this file. Here we have to change the name of the query sequence here as well. That will save the file t1a.ali, and then this is the last option. So it will give us alignment format files of two types. One is the pa.pap file, and one is the other one, that is PIR. So now just change the name of the script to alignment, right? .py. So using these files, when this will align, here we will go and run the command. Here just write alignment, and two files there, as I showed you, that one is the query sequence -t1a.ali file, and the other one, that is the two possible outputs. One is the query sequence -t1a, and the other one is query sequence -t1a.pap. Two files will be generated, and using the alignment file, you can analyze the inserted gaps in both the files of query and template, and also using the static.pap file, you can also analyze these things. So yes, so these are things which you may have to do, and here you can see that here is the alignment of the template, and using the .ala file and the .pap file, we can analyze the results of the alignment. Right, so let's wait for it to be completed. Let's wait for a bit more seconds. Hopefully it will be done soon. So depending on the internet and the file size, the alignment may take longer or shorter depending on your own sequences. So I think it's almost done. Let's wait for a few more seconds. Yeah. Oh, okay, it's done now. Oh, so these are the results of the alignment. If you want to analyze, I will not go into the details of all the alignment variables because this is beyond the scope of the tutorial, but in future we will talk about this thing probably in detail. So after alignment, next what you need to do is to go on the generate next step, that is to generate the model. And for generation of the model, we have already downloaded the scripts which are available on the modeler website. I am telling you again and again that all the scripts are available on the website. You just have to download those scripts and just change the variable names as per your interest. For example, here this is actually the script of the for generation of the model, and here the details are according to that example which was done on the website. So I will just change that example as per my my analysis, and now I'm just change the name, that is the query sequence dot, that is equals to the t1a.ali, and also the other details as per my example. And this model will actually give me a dope score, that is actually discrete optimized protein energy score. And this actually, I'll not go into the technical details because this is beyond the scope of the tutorial. So we just have to find this discrete value of the model, and this actually model means that the dope score is actually tells us about the accuracy and efficiency of the model. So let's see what we have to do. Just checking whether all the things are correct. Yeah, everything is fine. Let's go here and change the command as previously we did alignment. Now here model.py, and then click enter. Now again, depending on the file size and the internet speed and everything, it will take time. So here we have to wait for a few seconds, and then we will get the result from this command which we have given for to generation of the model. And this model will actually give us the dope score, and that dope score will tell us about the accuracy and efficiency, and we will select the model which will give us the minimum dope score. So lowest the dope score, better is the model. So this is the important thing which all of you should keep in mind while performing the analysis for generation of the model, right? So let's wait. This is actually the last step of modeler to complete and predict the structure of the protein which we are using here, like query sequence. Now the analysis or the script is done. Here we can go on the output file, that is actually the model.py. So the log file would be model.log. Let's see where it is. Here I think here, yeah, model, where it is. Yes, now this one model.log, that 91 KB file. So I'll just open this file, Let's open it on the better viewer, that is Notepad++. So here you can see that this is the result of the model structures which we have predicted, and let's go at the end of the file. There are so many details like bond length, angle potential, everything. I'm not explaining all these things because here I'm not just telling you how to perform all the analysis. And let's go at the end of the file. At the end of the file we can find the dope score. So this is actually a sort of evaluation and prediction of the model. Like we have now evaluated and predicted that minimum dope score gives us the best structure, but here now this is the result of the dope score. Here you can see that -3538 and all these values you can see for these are the 5 possible predicted structures, but here you can see that the minimum score here is this one. So we will select this B9990003 as the best possible structure of the model. Right now, in order to further evaluate the model, there are so many ways we can evaluate the model, but here I will explain one which is available on the modeler website, and that script is also available, that is to evaluate the model. And for that we will go through the basic details. So let's see what we will do with this in this step 5. Right, so there is another, the script number 5, which will give you the these are all the details. So here we will put the best model which was generated using the model.py script, that is actually B9990003. so we will change the name as our understanding here, that B9990003, and here change the name to query sequence. Right, okay. So this is the last thing we have to change in the evaluation of the model, and then this one variable as well, that is file. What we need to make is the file output name will be what it would be. Let's see here, that is T1A. No, that is query sequence. Let's say query sequence dot profile. Now these things are almost done, and just checking all the things are correct. Okay, everything is fine. Okay, complete underscore this and everything. Yeah, these all things are already available. You don't have to change much from the script file. You just have to change the names, and then you save it and rename it as evaluate.py, as we have talked about it. Evaluate. So you don't have to be a very good programmer if you want to run the this modeler script. You just have to you should just know that what you are doing. Here I'm just showing you example, so you should know what is your query sequence and what are your best templates, and you just have to then follow this process. Right, so this will, I'm just double clicked it, and now maybe it's running, and when that will be completed, then we will see later on. One more thing what I need to tell you is that to evaluate the model and to predict the model, to show the plot, see the plot of that model, we need couple of tools, or you can say that a couple of programs to generate the model. Number one is GNU plot, right, and which will give us the and that matplotlib package. We have to install these two things in our computer, right? So for that, we have to download these source code files, right? So here you can see that you can go on this GNU plot download, and from download you need to just click the files and source file, and it will download the code files, right? Here you can see, just download the latest version and it will start downloading on your computer, right? This is one thing what you need to do. The other is matplotlib. I've already installed it. I'm just showing it for your ease, so that you do not face any problems while performing the analysis. So matplotlib, go here and just download it from here. You can do these things together, right? So after this, when you download these things, one thing is also that you are using Python, right? So what you have to do is to go and check that what is your you can say what is the path of your Python, so that in that Python you have to install these two uh, packages of MATLAB, this one and the other GNU plot. So it's in C/Python, right? So here I will just write I'll go into the script here, right? And after that, what you need to do in C/Python, yeah, here you have to open that folder, or for example here, copy this. One more thing what you can do, copy this. This is the base. So you just have to make that path of the Python where the Python is installed, right? Then what you have to do is you go on the command prompt, because this is the system command prompt here. You just have to go into that folder where Python is installed. Oh, sorry, we have to go into the Python, so we have to write cd space Python, right? Write like cd. Let's see, cd space Python c/python. Yeah, now we are here. Now what we have to do is to put the command of metaplot, that is using the Python space -m space pip install matplotlib library, right? So it will, if you click enter, and then it will, yeah, now here you can see that now it's running, and now this is installed. So these both things are installed, and everything is done. So after installing these two, what you need to do is to run the plot and find that how the model is actually predicting your structure, right? So next, now it's done. Now let's go to the folder where the things are installed here, model bin, and then right, so yeah, like now we have to evaluation is done, and now I want to generate the plot, right? So to generate the plot, what I have to do is to use the script of plot underscore profile.py. This script which I will be using here, that is plot underscore profile.py. This script is also available on the website. You can just use that script here. As you can see that I have downloaded from an example. If I show you here that the evaluation is done, and all the evaluation you can see here, all the associations and the result. I'm not going into the detail as I have said you before, because this is beyond the scope of this tutorial. I'm just showing you how to run that. Now we go and click the, if you want to make the plot, we have just to run this script and insert our variables of interest, and then just run it like here. Run Python shell, and it will run model, and it will run the script. And after running this plot underscore profile.py script, it will generate a plot which will tell us that how best the model is fitting. So you can see that this is the dope score, and with dope score it is generating the model. So here you can see that red represents the model and green represents the template. So I think this tutorial is done here, so you can follow all these steps and generate your own model of interest, right? So in the next part of the tutorial we'll talk about Chimera, and I will explain you how to compare the models. Thank you very much for your time and patience.